In this video lecture, I'm going to discuss forward chaining and backward chaining, which is a part of your knowledge sharing, right? So, first of all, we should understand what is inference engine. After that, we'll discuss forward chaining and backward chaining. So, it is a component of the intelligent system in AI which applies logical rules to the knowledge base to infer new information. That means the main purpose of inference engine is to apply logical rule, right? Apply logical rule. Why to get some information, new information from the facts. So that is the main purpose of using inference engine, right? And first inference engine was a part of expert system. Inference engine commonly proceed in two modes. Your inference engine commonly proceed in two modes. Number one is forward chaining, right? First one is forward chaining and second one is backward chaining, right? So first we'll discuss forward chaining. What do you mean by forward chaining? Forward chaining is also known as a forward deduction or forward reasoning. Forward chaining is also known as forward deduction or forward reasoning. That means it is also known as forward reasoning method when using an inference engine, right? Forward chaining is a form of reasoning. It is also known as a form of reasoning which starts with atomic sentences. Which starts with atomic sentences in the knowledge base and applies inference rule. So, first try to understand forward chaining and backward chaining. As name suggests, forward. That means you are moving ahead. Is also known as forward reasoning method. First point. Okay. When using an inference engine, when you are using inference engine, it is also a form of reasoning. This forward chaining is a form of reasoning which start with atomic sentences. I have already explained sentences. We have two types of sentences, atomic and compound, right? In the knowledge base, which applies inference rule. That means we are applying inference rule in the forward direction. It's a forward chaining. That means in the forward direction to extract more data until a goal is reached. Second, second most important point is forward chaining algorithm start from known facts. So this algorithm will start from known facts, right? And add their conclusion to the known facts, and it will add some conclusion to the known facts. The main point you should consider in forward chaining that it will start from known facts. Properties of forward chaining. Few properties are given. It is a down up approach. This forward chaining is a down up approach. That means it moves from bottom to top, right? It moves from bottom to top. It is a process of making a conclusion based on known fact. I have already told you that it is start with known fact, that it will that means it will make a conclusion based on known fact starting from the initial state. And forward chaining approach is also called as data driven, right? As we reach to the goal using available data, so it is also known as data driven. Forward chaining approach is commonly used in the expert system. These expert systems are given. Now let's see an example. With the help of example, we can easily understand forward chaining. Let's see an example. So total four statements are given, right? That means it's a known fact, right? And on the basis of known fact, uh, with the help of forward chaining, using the given known fact to prove Tommy is black, Tommy barks, Tommy eats bone. So you have to prove these conclusions. First of all, understand what are these statements are given. First statement, if D bark and D eats bone, then D is a dog. This is your first statement. If V is cold and V is sweet, then V is ice cream. Third statement, if D is a dog, then D is black. Fourth, if V is ice cream, then it is vanilla. That means total four statements are given. So with the help of these known facts, you have to prove Tommy is black, Tommy barks, Tommy eats spoon. Okay. Now discuss the solution. Now I'm going to discuss the solution of this problem. So given Tommy barks, first is Tommy barks. So how will you prove this? Yes, Tommy barks. From one. From one statement, first statement is saying if D barks and D eats spoon, then D is a dog, right? So Tommy is black. That means from first it is clear. If Tommy barks, if Tommy barks, you can replace D with Tommy. If Tommy barks and Tommy eats bone, then Tommy is a dog. From 3 it is clear. What is 3 statement? Third is saying if Tommy is a dog, if D is a dog, replace D with Tommy. If Tommy is a dog, then Tommy is black. So Tommy is black, clear. Tommy eats bone, clear. Now second, Tommy barks. This conclusion is remaining, right? So when Tommy is black, from third it is clear, right? Hence it is proved Tommy is what? Tommy is black. Statement 3 is saying if D is a dog, then D is black. So if Tommy is dog, that means Tommy is black. So it's an example of forward chaining. Now let's discuss backward chaining. Backward chaining is what? It is also known as backward deduction and backward reasoning, right? A backward chaining algorithm is a form of reasoning which start with the goal. In the previous case, that means in forward chaining, what we were doing, this algorithm, forward chaining algorithm, it follows from the known fact, from the initial state. It start with the initial state, but in backward chaining, it start with the goal. That means you can say with the final state. Goal is what? Goal is a final state. So it will start with the final state. That means you can say the goal and works backward, chaining through rules to find known facts and support the goal. Forward chaining start with a known fact and it will find what? It will chaining through the rules to find known fact, right? So a few properties are given. Your forward chaining is what? And your backward chaining is top down. And backward chaining is based on this inference rule, that is modus ponens rule. And backward chaining, the goal is broken into sub goal and sub goal to prove the fact, right? That means your goal will be broken into sub parts, sub goals. It is called a goal driven approach. It is called a goal driven approach. So next point, backward chaining algorithm is used in game theory, automated theorem, providing tool, inference engine, and so on. This chaining method mostly used in DFS, depth first search strategy for proof, right? So again I'm going to take an example so that we can easily understand backward chaining. So example is given 1, 2, 3, 4, 5, 6. Total 6 statements are given. So with the help of 6 statements, you have to prove that Geeta loves kurti. Geeta loves kurti. So solution, convert the given axioms into FOPL. So FOPL, first order predicate logic. So it's very clear. Clothes X, all types of clothes. Geeta loves all types of clothes. It's your statement 1. Hmm? So clothes X implies loves Geeta X. So you will easily convert this statement into FOPL. I am not going to explain how to convert this statement into FOPL because in the last video lecture I have already explained how to convert your normal statement into FOPL. That means, sorry, that means in resolution. In resolution in FOPL, in this video I have already explained. So when you will convert these statement into FOPL, then you can easily find loves Geeta comma kurti, right? So with the help of this graph you can easily understand loves Geeta comma kurti, that means clothes kurtis, that means clothes kurtis, and cloth kurtis can be further divided into wears and negation of bad Gita. So hence you can say Gita loves kurti, right? So it is all about forward chaining and backward chaining. So if you have any doubt, you can comment and you can ask your queries in comment section. So thank you so much for watching this video.